Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 540 that says single element in sorted array. So yeah, as the question says, you will be given one sorted array, right? And you need to find the single element in that sorted array. See the array would be something like this, where each element occurs twice all the elements, but except for one element that will occur once. So here it is saying the same thing, that consisting of integers where every element appears exactly twice, right? And only one such element that occur exactly once, correct? So we need to find that single occurring element, and the complete array will be sorted array. And the question says that you must run in big of log n time and big of 1 space. Okay, so yeah, as you guys can see here that in this array that this 2 is not repeating. So yeah, it is a single element, that's why we written 2 here. Same thing here also, that we have 3 3 7 7 10 and 11 11. So 10 is not repeating, so 10 is our answer for this nums array, right? So yeah, now the question is simple, right? That you need to find the single repeating element, that you can use hash map to store frequency, and any element with a frequency 1, then that is our answer. Okay, and by doing this, the time complexity here would be big of n, and also the space complexity is big of n, correct? By using this hash map version of solution. See, this is the first solution, right? Now the second solution is why to use hash map, because the elements are sorted. See, elements are sorted. So if let's say so that means that if an element is appearing twice, then it must be in the pair. So what pair? It's pair like this, like 1 and 1. See, the adjacent element would be the same, right? And for 2, the adjacent element is not same, and that's why it's our answer. So here I am telling that if you have something like this 1 1 2 3 3 4 4, so we will check this adjacent element. Is the adjacent element same? Yeah. Is the adjacent element same? No. Then 2 is our answer, right? So by checking this, our space complexity, see, let me write it here, it is time complexity, space complexity. Here time complexity would be big of n, and space complexity is big of 1, right? Why big of n? Because let's say you have something like this in the worst case, 3 3 and 4, that is the last element is not repeating, then in that case you have to traverse all the elements, correct? So that's why the time complexity here is big of n, and the space complexity is big of 1, because we are not storing anything like hash map or something. So this is a slightly better approach than this hash map version. Now we will talk about this third type of approach, where it will satisfy the current constraint of the question, that is time complexity must be big of log of n and space complexity is big of 1, right? So yeah, there is only one approach where you can reduce the time complexity for this type of question to big of log of n and space complexity is big of 1, and that is what? That is binary search. As you might know that binary search is the only algorithm with the time complexity big of log of n that can be applied on any arrays, right? See here why binary search will work. Since for any question to make binary search work, what you need two things. You need to require only two things. First is sorted array, and after the sorted array you need some target value. Okay, what binary search does is, in binary search we find the index position of the target value in the what we can see in the primary binary search or the fundamental binary search, right? We just search for the index of the target value in a sorted array. That's how binary search works, right? But here we need to make some variation. So this question is a bit variation of the binary search, correct? So yeah, so I hope you guys understood that why binary search will work here, because we have both the things, some sorted array and some target value repeating once. Okay, this target value is what? The value that is repeating once, correct? So yeah, we need to find this repeating once value in this sorted array. So now let's move on towards the approach, how we will approach this question. So let's say you have some array like this, 1 1 2 2 3 4 4 5 5. So let's say you have something array like this. So let me also write down the indexes. See, one thing to note here is that see, here is the breaking point, right? As you can see, the 3 is only repeated once, right? So it is the breaking point, and before this breaking point and after this breaking point there is some change. There change in the index. So before the breaking point, what you can see, that any number start from the even index. See, this is even index, this is even index, like this even index and odd index, they are repeating. Even odd pair is there, even odd, even odd. That I am talking about here, that even index and the odd index pair are same, means the adjacent pairs are like this and they are of type even odd, even odd, right? But after this 3, you can see the pairs are of 5, 6 and here 7, 8. Here the pairs are of odd even, like odd even. See, the pairs change from even odd to odd even after this change, because this 3 is only repeated once, right? So this changed the complete pattern. Before this it was even odd, even odd. If there would be more elements, then all would be even odd. But after this single repeated element, it is odd even, odd even. So what we can found here, so we found here that while doing binary search, see, in binary search we have something like mid, right? If you know the binary search, we have 3 variables, low, high and mid. So somehow if we can check that if mid is even, let's say mid modulus 2 equals to 0, mid is even, then what we can check that if mid equals to mid plus 1. See, if mid is even, then its adjacent pair to be same. That means if this is the condition, like mid equals to mid plus 1, that means even and odd condition is there. Then in this case, where our answer would lies to the right hand side. So in this case, what we would do, we would simply make low equal to mid plus 1, because if you find such type of pair, even odd, then we go towards the right hand side, because the single element would be on the right hand side. Okay, got it. And yeah, if this is not the case, so this is if condition, and in the else condition, what we would do, we would simply do high equal to mid minus 1. Why? That means if this is not the case, even odd is not the case, then what would be the case? It would be odd even case. So if you find something like odd even, then our answer would towards the left. So this is towards the left, high equal to mid minus 1. Okay, so I hope you guys understood that what we are trying to find out here. So we are simply trying to find out that what type of pair is that. Is it even odd pair or odd even pair? And if it is odd even pair, then we have to move towards the left, and if it is even odd pair, then we have to move towards the right. Simple as it is. So yeah, I hope you guys understood this approach, that what we are trying to do here, and based on this indices value, that either it is odd or even, we will check for different conditions, right? So yeah, now let's move on to the coding part, where we will see the code for the solution. Okay, so here first I started by taking this base condition that if n equal to 1, that means the size of the num set is 1, then yeah, the answer would be the first element itself, correct? Okay, then I took this low and high, that is the starting element and the last element, correct, and calculated the mid. Now this, what is this condition? So let me write down here. So this is one of the base condition. You can say that if the mid here, what is we are doing here, the mid is 0 and mid is not equal to mid plus 1. So let's say you have something like this, 1 2 2 3 3, that means the starting element is itself not repeating. Then in that case, that is our answer, correct? So yeah, we return nums of mid. So this is the condition 1. Okay, now let me talk about this condition. Okay, so if you have something like this, that 1 2 2 1 1 2 2 and 3, this is condition 2, that the ending element is not repeating. That means the mid is not equal to mid minus 1, sorry, the mid equal to n minus 1, that is it is an ending element, and mid is not equal to n minus nums of n minus 2, that means this and this are not same. Then in that case, this is our answer, correct? So yeah, we return that mid element. So in this third case, what we are checking something like this. So let's say we have something like this. So, and this is our mid, and this mid is not equal to previous and not equal to next, correct? It's not equal to previous and not equal to next. Then this is our answer itself, our answer, right? And that's why we simply return this as our answer. Now after checking all this, what's remaining? So remaining thing is that that if you have something like this, something that given in this example, right? So if you found so here what is n equals to 1 2 3 4 5 6 7 8 9 9. So here let's say low is 0 and high is 8. Okay, and what you will get mid in the first iteration. Let me write it this way. So here in this example, what would be the low, high and the mid? So initially the low is 0, high is what, 8, and mid is what, 8 plus 0 by 2, that is 4. So here what is the fourth index element? So fourth index element here in this example is this 3, this one 3. Okay, so yeah, here none of this condition will get passed, correct? So we move. Now if the mean modulus 2 equals to 0, right? So we go in this else if condition, this one. So here if we check if mid equals to mid plus 1, that means that mid is even and we are finding even odd condition. If even odd condition is there, no, here this is fourth index and fifth index is 4. The even odd condition is not there. Here we have odd even types of pair, odd even pair. So in odd even pair, what we have to do? We have to move left. So yeah, we move left and we change high to what? Mid minus 1. So the high becomes 3 or a low becomes 0 itself. Now we again loop, and at this point what we will get? Mid equals to 0 plus 3 by 2, that is 3 by 2, that is 1. Okay, correct? Yeah. Now here what is the element at index 1? The element at index 1 is 1 itself, right? Now you will check for all this condition, it won't pass again, and you will check if is mid modulus equal to 0. No, this is not equal to 0. So in that else case, now this is the case, right? Here what you will check, that if mid equal to mid plus 1, say mid is itself odd, and if it is equal to mid plus 1, that means we are checking odd even condition, right? And whenever we find odd even condition, we move towards the left, and even odd we move towards the right. So we check, do we have odd even condition? This 1 and 2, no, this index at 1 and index as 2 are not same. Then we know that low equal to mid plus 1, right? And we this is even odd condition. As you can see that we are at here, this is index 1 and here we have even odd condition, its previous element is same. So whenever we have even odd condition, we move towards the right. We move, so we make low equal to mid plus 1. So now high is 3 and what is low? Low is 1 plus 1, low is what? 2. Now 3 plus 2 is 5, 5 divided by 2, it is what? 2, right? It is index 2, and what is in value of index 2 is 2 here. So we will check. So now when you have this in the iteration 3, you will see that nums of mid is not equal to mid minus 1 and it's not equal to mid plus 1. So this else if condition will get hit and you will get your answer, because 2 is a single element and the previous element is not same and the next element is not same. So here this at the third iteration, this else if condition will get hit and you will return mid, that is this element 2, right? So yeah, I hope you guys understood the dry run of this question, that how each time we are updating the low and the high, by what we are checking. We are checking this even or odd even, and we know that each time if that is even odd, then our answer is towards the right, and if we find odd even, the answer is towards the left. What does this right mean? The right mean we have to do low equal to mid plus 1 and left mean high equal to mid minus 1. The simple as it is, right? So yeah, this way the binary search works, and you might have seen that in less number of jumps we can go towards the answer, correct? So yeah, the time complexity here as mentioned, it would be big of log n. The space complexity is big of 1, as we are not storing anything. So yeah, this is how this approach works, the binary search works here. So yeah, that's all for this video. If you guys have any doubts, then do let me know in the comment section, and make sure to like this video and subscribe to our channel. Thank you.